Dear students of Middle 3, welcome to our first lesson of second term. This lesson talks about chemical reactions. Sure, you have heard about this expression of chemical reaction, and we know that chemical reactions are very important in our daily life. We can make benefit of chemical reactions in many fields of life. In industry, like the industry of papers, industry of glass, of textiles, of fertilizers in agricultural field, or in medicine, for example. If you observe a bottle of medicine, you can observe or you can see here the ingredients or the components of the medicine as some chemicals which are added together to form the medicine which you take. In this way, these reactants or these chemical compounds are reacted together to form a new compound which is suitable for drinking as a medicine. Also, chemical reactions, as we said, are very important in many fields like industry and agriculture. Chemical reaction also is important in the process which is a plant makes to make its own food, which is photosynthesis process, in which it absorbs water from the soil and carbon dioxide gas from the air. To see here or to understand the concept of the chemical reaction, let us to see here this what happens during the chemical reaction. The formation of water. We know that water consists of 3 atoms. A drop of water, as you can see here, consists of what? Consists of 3 atoms. 2 hydrogen atoms and 1 oxygen atom, as you can see. But how can water form it? Water formed during this chemical reaction here by reacting or the combination between the hydrogen atoms and oxygen atoms. As you can see here, hydrogen atoms which are colored white, as you can see, and the oxygen atoms are colored red. What happens? These are H2 and O2. They are the reactants. What happens here? As you can see here, the atoms are separated from each other. Separated, I mean that the bonds which link between them are broken by the energy of heat. Then here, H2 and O2 are called reactants, while H2O, which is produced, is called the products. Here the bonds are broken. These are the bonds which link between hydrogen atoms and oxygen atoms, as you can see before the chemical reaction. These bonds here are broken. These bonds are broken of reactants, as you can see here. And new bonds are formed after the reaction in the molecules of products, which is water. So we can define here the chemical reaction as what? The breaking of bonds in the molecules of reactants and forming new bonds in the molecules of product. This is the formation of water, and this is called what? This is called the chemical. So we can define here the chemical reaction as what? As breaking of bonds in the molecules of reactants and forming new bonds in the molecules of products. We have many types of chemical reactions, but the types which we'll study in this lesson include these types only: thermal decomposition reactions, substitution reactions, and oxidation reduction reaction. In this period, we will study only the thermal decomposition reaction. Thermal decomposition reactions means here the main compound can be decomposed or can be dissociated into other simple compounds or other elements, or that the elements which here are included in the composition of this compound by the effect of heat. As we said, thermal means heat. The compound here decomposes into what? Decomposes by the effect of heat into its elements or simpler compounds. Like the examples which we will study in this reaction, a compound which is called mercuric oxide. Mercuric oxide decomposes by the effect of heat into mercury and oxygen. It changes from red color to silver color. changes from red color to silver color, and the oxygen gas evolves. As you can see here, this is red mercury oxide. By heating it changes into what? It changes into silver color. As you can see, silver color indicates the formation of mercury. So we can say that HgO, which is mercury oxide, decomposes into Hg, which is silver, and what? Oxygen gas. Another example, which is here copper hydroxide, which is blue color. By decomposing it changes, as you can see here, into black color, which is copper oxide. So copper hydroxide, CuOH by 2, decomposes by the effect of heat into CuO, which is black color, and water vapor evolves. Another one, which is copper carbonate, which is green in color, as you can see here. By here heating it decomposes into copper oxide, which is black color, and here carbon dioxide. Also, I have here sodium nitrate, which is white in color, as you can see here. By heating it changes into yellowish white color. Observe here the change of the color from white into yellowish white, which this yellowish white is what? Is sodium nitrite. So NaNO3 changes into NaNO2 plus oxygen. So these are the equations which we study here. Mercury oxide decomposes into HgO, as you see, decomposes into Hg and O2. Another one, copper hydroxide, CuOH by 2, changes from blue color into black color, which is copper oxide. This is one. Also, I have here, as you can see here, copper carbonate, CuCO3, green color, changes into copper oxide, CuO, and which is its color is black, and the carbon dioxide gas evolves, which this carbon dioxide gas turbines the clear lime water. Another one, which is copper sulfate, CuSO4, blue color, changes into copper oxide, which is black in color, and sulfur trioxide. Sulfur trioxide, this gas SO3, has the ability to dissolve in water, forming sulfuric acid, H2SO4. The last one, which is sodium nitrate, which is white in color, NaNO3, decomposes by heat into sodium nitrite, NaNO2. Its color is yellowish white, and the oxygen gas evolves. Okay, that's about here. When you are asked here, give reason formation of silvery color on heating red mercury oxide, you can answer due to the formation of mercury, which has silver color. Formation of black substance on heating blue copper hydroxide. Why? Due to the formation of copper oxide, which has black color. Give reason also, a yellowish white color is formed on heating white sodium nitrate, due to the formation of sodium nitrite, which has what? Yellowish white. So in this case here, NaNO3 gives NaNO2 plus O2. Or you can here answer by using the equations directly, and you will get the full mark also from this answer. The remaining part here of this thermal decomposition reaction, which is application, which this application talks about the airbag. What about airbag here? Airbag, you know here, this is used in modern cars. Here the airbag, as you can see here, contains sodium azide. Sodium azide is this compound here decomposes by the effect of electric spark. NaN3 to give nitrogen gas like this way. So it exploded here. So it avoid accidents in the modern cars. This is the function of the airbag. It's very important in modern cars, as you can see here. Okay, this is the importance of it. So when we say that the importance of airbag is what? It is one of the safety means in cars during emergency. On the occurrence of an accident, as we said, electric spark is generated, causing the decomposition of sodium azide here, which is NaNO3, which is present in the airbag. And nitrogen gas here is evolved. This nitrogen gas here causes the inflation of the airbag, protecting here the driver from being or from having accident. So in this way also airbag is considered as what is considered as an application for the decomposition of the compound. These are here the types of the thermal decomposition, or the examples which we studied in this lesson of thermal decomposition reaction. This is the first type of chemical reaction. The next part of this lesson, we will study the other two types of chemical reactions, substitution and oxidation reduction. We reach the end of our period. I hope you understand, and goodbye, my students.